Good afternoon, everyone, and thank you very much for joining us. So today's webinar will focus on the circular medtech, starting with the design. So while we are going to organize this webinar is because in recent years, circular economy principles have entered the healthcare conversation, often framed around waste management or recycling. But research consistently shows that most environmental impacts are locked in the very early stage in the design phase, like the material selection, product architecture, durability, reusability, and service models are all determined very early in the development stage. So today I would like to shift the focus upstream to explore what it really means to embed circular thinking into the design of medical devices. So let's start with a bit of our housekeeping. So first, please keep your microphone muted while speakers are presenting, and this webinar is being recorded and will be available on our website. If you do not wish to be included in the recording, please keep your camera off. There will be time for Q&A at the end of the presentation. Please add your questions into the chat along with the presentations. So the agenda, so I will begin with a short introduction to DECHI, which brings us together today. Then I will introduce the concept of eco-design in in medical devices, focusing on how eco-design is increasingly important for medtech sector. Following that, James Praise will explore how changing demands are reshaping the medtech productive development and what adopting circular principles means in practice for industry. And Dr. Jingpu from AMRC will then discuss the importance of a data-led approach in building a robust evidence base for circular design. Dr. Roger Singleton will demonstrate how the digital tools like the artificial intelligence can help accelerate the data collection, modeling, and sustainability reporting. And finally, we hope this session provides not just insight, but also practical directions on how circular principle can be embedded into medtech innovation. And firstly, let me briefly introduce the DECHI project, which is the digitally enabled circular economy healthcare innovation. So it is a UKRI EPRC funded research project running over 3 years from January 2025 to December 2027. The project is very interdisciplinary. We're working with partners across government, the NHS, the industry regulators, and digital innovation networks. So we investigate how digital technologies can enable circular innovation in healthcare, making the system more sustainable and resilient. Rather than focusing only on recycling at the end of life, we look at how digital tools can support reuse, local generation, remanufacturing, and redistribution, keeping value in the system for longer. Our focus is medtech sector, the medical devices, where design decisions, material use, and regulatory constraints make circular transformation both very challenging and high impact. So in DECHI, we have 4 work streams. Firstly, work stream 1, which is led by University of Exeter, and also I'm working for the work stream 1. So it's to build the medtech evidence base. And work stream 2 focuses on sensorization and simulation, led by University of Sheffield. Work stream 3 explores digitally enabled delivery, led by University of Cambridge, and workstream 4 addresses the whole system adoption, also led by University of Exeter. And importantly, stakeholder engagement runs throughout the project, ensuring collaboration with research networks, policy makers, and also industry partners. So this project has a very interdisciplinary team combining circular economy research, engineering design, digital technology, and regulatory expertise and healthcare innovation to address the circular medtech as a system challenge. And it is also worth noting that DECHI sits within a wider research network. It's called DICE Network Plus, also led by Professor Fiona Charnley, which connects 9 research projects across the UK. It offers targeted funding opportunities, including feasibility studies, demonstrator projects, and knowledge exchange placements. So it focuses on 2 key challenges. Firstly, embedding sustainability, and second, using digital advances to accelerate wider adoption of circular economy principles. So if you want to know more about our project, or if you are interested in the funding opportunities, please check our website and contact our project manager, Georgie. So yes. Today, let's begin our webinar, the main content of the webinar. So today I'm introducing the eco-design in medical devices. So it is an approach that integrates environmental considerations into device design from the very beginning. So in healthcare, safety and performance are rightly prioritized, but increasingly we also face urgent challenges around carbon emissions, material use, waste reduction, and supply chain resilience. Medical devices, from the single-use consumables like gloves, syringes, to very complex electronic equipment like MRI, ultrasound scanning, imaging, contribute significantly to these pressures. So firstly, why eco-design is important. So just in UK alone, so around £10 billion is spent annually on medical device, medical technology, and a significant proportion of that spending goes towards single-use disposable devices. At the same time, the NHS generates about 156,000 tons of clinical waste each year, much of which arises from device use. Clinical waste is particularly carbon intensive because it often requires high temperature incineration for infection control purposes. So in work stream 1 of DECHI, what we have found is one important strategy, shifting from single-use to reusable, remanufactured devices, and the life cycle evidence suggests this can reduce overall carbon emissions, lower long-term procurement cost, decrease volume of clinical waste, and also contribute to the NHS net zero commitments. And what we mean by eco-design in medical devices based on the BSI definition, eco-design is about the rethinking device development to consider the entire product life cycle from material extraction to the end-of-life recovery. So in medtech, this means designing devices to minimize environmental impacts, extend lifespan, and also enable reuse or material recovery, and also design the devices which can be easily disassembled, repaired, or upgraded. So it is not just it is increasingly being formalized in the standard. For example, the AAMI TAR 65 guidance emphasized the embedding sustainability criteria to early design decision makings. And so it's and also conducting life cycle evaluation and planning for the responsible end of life. This is where the life cycle assessment becomes very critical because it provides quantitative evidence to identify environmental hotspots across the life cycle, avoid burden shifting, and compile design alternatives, and also support regulatory and procurement requirements. So in the UK, under the NHS delivering a net zero NHS strategy and net zero supplier roadmap, suppliers to the NHS are now required to meet progressively stricter carbon transparency requirements, which means access to the NHS market becomes conditional on carbon disclosure and sustainability performance. So in contrast to the UK's procurement-driven approach, the European Union is embedding eco-design directly to product legislation through the Eco-Design for Sustainable Product Regulation, the ESPR, adopted in 2024. This makes a significant shift, and under the Article 5 of this regulation, it introduces a wide set of the potential design requirements, including recycle content and energy resource efficiency, durability, reliability of the products, and also the possibility of remanufacturing, recycling, and the recovery of the materials. And for medical devices, while specific implementing acts will determine the scope and the timeline, but the signal is quite clear. The environmental performance attributes are becoming product characteristics, very importantly, alongside the safety and functionality. So this slide brings to very important research on the eco-design of medical devices. On the left, we see the circular healthcare flows in research, design, development process. The key idea here is that the circular strategies should be considered from the very early beginning, even before the technical development starts. And this includes questions such as, do we really need this product? Can we provide the same function in a more sustainable way? Can we enable sharing, multi-functions, or service-based delivery? Or can we design for reduced material use, lower energy demand, and extended lifespan? So this reflects the hierarchy of the circular strategy: refuse, replace, rethink, and reduce before moving to the reuse, remanufacture, recycling, and recovery. And on the right side, the figure maps the quantitative and qualitative methods onto different stages of generic design process. For example, at the early stage, concept development may use material flow analysis and simplified screening LCA. And in the middle stage, design may apply detailed life cycle assessment, circularity indicators, and at the late stage, evaluation may integrate LCA analysis, maturity grades, material flows. The key message is that eco-design is not a single tool. It is a structured integration of multiple assessment methods alongside the design process. And LCA is the most widely used quantitative tool for evaluating environmental impacts across the product lifecycle. So if circular medtech begins at design, the next question is how we operate that in the practice. So I will now pass to James, who will build on this foundation and explore the next stage of the implementation. James, over to you.
Brilliant. Thanks for the introduction, Jin. Good afternoon, everybody. My name is James Priest, and I'm the Chief Operations Officer at BioFizz. We are a life sciences consultancy that's based in South Wales, and our goal is really to help academics, startups, and SMEs, bring their ideas from the laboratory, from that idea concept, to real life and products. So our core team represents an experienced blend of scientific knowledge, business development, project management, and regulatory expertise. And we actively support a portfolio of clients across diagnostics, medical devices, novel antibiotics, and vaccines across human, food, and animal health applications. But the focus of my talk today is a project that we led development back of in 2025, which is called Dose Doctor, which is a fantastic real-life and worked example of the rising importance of sustainability in device design. Now, Dose Doctor is a safe and effective ergonomic tool for storing, dispensing, and tracking liquid medication use for children and the elderly. Sorry, Jim, can you go back a slide just quickly to finish off? But it was funded with support from the Welsh Government, and we're at a stage of development where we have high fidelity prototypes, and we're looking towards design for manufacture. But we're always on the lookout for co-development activities. So if any of the audience and your expertise in sustainability thinks they can help us, please do reach out so we can bring it a step closer to market. Next slide, please, Jin. Now, the Dose Doctor original concept was developed to address a very scary incident that occurred within the home of the original inventor of the product. And like many of us, they have a medicine cabinet in their bathroom, that is poorly maintained, full of medications for conditions that we no longer have and we're no longer or unlikely to need again. But the problem was that the youngest son, who was left unsupervised to play, eventually gained access to a very high-strength bottle of adult opioid medication, and he overdosed himself. Luckily, they found him in time. He was lethargic. They rushed him off to hospital. He had his stomach pumped, and whilst they spent a few days in hospital, fortunately, he made a full recovery, and there was no long-lasting effects of the incident. But the incident itself really stuck in our minds, and that's when we started to investigate the problem. And we realized that this is not an isolated incident. There are millions of medication errors that occur at home and in hospitals every day, and they can be very serious because liquid medication affects two very vulnerable patient groups, primarily in children and the elderly, because they are almost exclusive users of liquid medication. So once we sat down and thought about the problem, we decided to design a solution that would help to ensure that in future, medications by both trained and non-trained persons could be confidently and safely dispensed, whilst also walking the important line that, when unintended, these could not be accessed independently by unsuspecting children. Next slide, please, Jen. So this is the current day, generation of Dose Doctor. So we have a single-use reusable dispenser that is used with several 5 ml cartridges. They can be pre-filled and then stored in a lockable storage container. The device incorporates a combination of useful design features intended to protect the user, or make it easier to use. So the dispenser is deliberately small, so it can fit into a mother's hand and can be dispensed one-handed while holding a baby. The cartridges can be pre-filled, so they can be ready to use in the middle of the night or out and about, so that they can be prepared with no fuss. The safe storage system uses a tab lock mechanism to help prevent or at least delay young children gaining access to the medication stored inside. And there's also a small magnetic reminder dial to help record when the last time the medication was given. Next slide, please, Jen. Now, the design itself had been very well received, and just before Christmas, we were actually notified that Dose Doctor had won not just one, but 2 European Product Design Awards in both the baby and maternity safety product categories and the healthcare medicinal product categories. Our prototype has gone through 2 stages of usability testing with parents of young children, and I think we're starting to become quite confident that what we're developing is a solution to address a lot of the complaints and incumbent techniques and common practices that lead to medication errors. We've also begun to explore opportunities within clinical use, speaking with experts at NatSpec, which is a special educational needs provider, as well as representatives from the UKHSA's Poisonings Information Team. We also have an active study with Cardiff and Vale University Health Board, which is helping us to identify opportunities for use in acute care and elderly care homes. We should get a first glimpse of this piece of market research in early March. Next slide, please, Jen. So Dose Doctor has been in development for about 18 months now, and I think it's faced all of the traditional challenges, if we can call it that a new idea, heading to market does. Like many other technologies, we have limited funds and need to prioritize certain tasks so that we can reach milestones that ultimately unlock new investment and development opportunities. So using our past experiences at BioFizz, we anticipated quite a lot of these challenges, making sure that we had adequate customer input. We work with really good product designers to implement important design features, understand the Class 1 regulatory pathway for medical devices. But one of the most unanticipated areas that we had to focus on became sustainability. Next slide, please, Jen. And this was a point that was highlighted to us by an investor we were speaking to about 12 months ago. And they asked a very pointed question about midway through our pitch, which is, what is our plan to address the sustainability of our plastic-based product? Now, I think at this point in time, we'd already considered this as part of our business plan. We'd outlined some very broad steps that could be implemented at a later date. We knew that we could become B Corp certified, show our commitment to sustainability goals and fair employment practices. With our competitors, there are some examples of recycling schemes, also identified suitable sites where we could recycle plastics if they couldn't be disposed of in the national recycling schemes. And I think importantly, we knew that once we were established, we could investigate more sustainable materials, benefiting from the higher volume of manufacture and have a little bit more resource that we could explore this kind of problem set further. So after this call, the investors seemed pretty placated. We finished the meeting, but a few days later, we received an email and it outlined that whilst they love the idea and our passion for it, they couldn't get away from this idea of a single-use plastic. No matter how much we explained that this could be reused or we had plans for X, Y, Z, the ultimate answer for investment was no. And this was a story that sort of repeated itself when we started investigating non-dilutive funding opportunities as well. We are seeing much more frequently questions about our decarbonisation plan. How would our innovation help the NHS meet its sustainability goals? And even with ongoing interactions with Welsh Government, as BioFizz, we're becoming asked, how does our activities support the Wellbeing of Future Generations Act? This is already coming to the fore. But our first result, thought to this line of questioning was a little bit defensive, I think, in honesty. We were always the little guy. This was a lot of scrutiny for a small company with a brand new idea, with no market share, and importantly, very little funding allocated to these types of activities. So the questions we started asking ourselves was, is it fair? Should we be answering these questions? And just to put this in time, we'd manufactured less than 10 of these units. We had no idea about the tolerances of our design, drawings when moving to injection molding. So, our first thought was, was this just a go away answer for investors? Single-use plastic are bad is a very reproducible soundbite, but out of context, we all agree with this statement. But yet nobody would blink if they were part of a necessary life-saving invention. And the final thought we had was around our competitors. Was Calpol having this kind of scrutiny? They are probably very aware that their products last less than a month, and I bet I can go into any parent's house, go into their cutlery drawer, and find a handful of unused Calpol syringes. Whilst they operate a recycling scheme, how successful is the scheme? We sort of got into a bit of a negative spiral as to fighting against this rather than leading into it, and finding out how could we get better at this changing game, because we ultimately need to play it for our products to be successful. So the question we started asking ourselves was, how do we take action? How could we take convincing steps to demonstrate that we'd really thought about this issue and could take the appropriate next steps to market? Immediate steps, impacted onto our design. We began to look at the lifetime of the dispenser. Could we switch to a CNC produced aluminium component? It would increase our cost of goods, but it also, as a side effect, increased the luxury feel of the item and improved its durability. Could we become more efficient in the use of material? Could we make the walls thinner without compromising, the intended safety of the device? Could we start looking at opportunities to rewash and reuse the syringes? But we had plenty to think about when it came to the design. But that was hard to communicate to, investor or a question or a grant application. So because we're scientists and engineers, we wanted to quantify this. We needed a line in the sand, understand where we are currently, and once we understood our impact, how can we take steps to mitigate this? So last year we started a project with the AMRC and to begin, understanding our life cycle analysis of our product, which I think leads neatly into Jing's talk. So next slide, please, Jing. And then, with that introduction to Dose Doctor and our journey, I look forward to having a wider discussion and Q&A at the end of this seminar. So Jing, take it away.
Hello everyone. I'm Jing Pu. I'm a senior manufacturing research engineer at MRC. Building on James' design vision, I'm going to walk you through the evidence base of this project. Next slide, please. So we will explore the LCA framework used for BioFizz, key findings from our comparative assessment, and how this data steers commercial decision-making. Finally, I'll discuss the future of rapid assessment and how we bridge the gap between complex data and concurrent design. Next slide, please. This project supported BioFizz in developing the Dose Doctor, a novel solution for liquid medication. Research identified 5 key areas to enhance sustainability across both product and business development. As shown in the Venn diagram, we balanced the environmental, economic, and social pillars, ultimately selecting life cycle assessment, or LCA, as our primary tool to measure the impact. Next slide, please. Our framework followed the ISO 40040 standard, conducting a comparative LCA between the Dose Doctor and the standard Calpol syringe. We defined a cradle-to-gate system boundary and used a DECHI unit as our functional unit. We tracked the multiple impact categories, including climate change, ecotoxicity, and resource use, etc., utilizing the environmental footprint 3.1 method. Next slide, please. For the inventory analysis, we calculated the bill of materials by assigning specific material mass within the CAT model. This flow diagram illustrates the life cycle stages from raw material like polypropylene and aluminum to the manufacture processes like injection molding and CNC machining. Note that the elements in gray, assembling, transportation, use, and disposal, were initially considered out of scope to focus on the manufacturing impact. Next slide, please. Transparency in data is crucial. We use a mix of primary data and secondary data from the EcoInvent database. We assumed specific logistics to build a realistic environmental profile for the dose doctor components based on likely supply chain routines. Next slide, please. To provide a baseline, we performed a similar analysis for the Calpo syringe. This is a much simpler two-component polypropylene design. Again, assembling to disposal were marked outside of the initial scope to ensure we were comparing the cradle-to-gate process of both devices fairly. Next slide, please. Assumptions for the Calpo syringe were modeled on a high-volume manufacturing facilities in the UK Midlands. Johnson & Johnson brand was chosen due to the market prevalence, with raw materials sourced from Europe, a robust real-world benchmark for our comparison. Next slide, please. The initial results showed that due to the complexity and durable materials of dose doctor, its manufacturing impact was significantly higher across all categories, including climate change and resource use. However, these results do not account for the full life cycle. To find the true environmental values, my colleague Chloe Suter conducted an additional comparative assessment based on the use phase. Next slide, please. Chloe looked at the use phase scenarios based on NHS and pediatric data. While a Calpo syringe is often replaced with every bottle, the dose doctor is designed to be reused throughout a child's lifetime. We calculated that an average child might consume over 6,800 milliliters of medicine up to age 14, the equivalent of 34 large bottles or 68 smaller bottles, and potentially 34 discarded syringes and 68 discarded syringes. Therefore, potentially between 34 to 68 discarded syringes. Next slide, please. When we look at the lifetime impact in Figure 8, the narrative shift, the original dose stock design showed no improvement if only one unit was reused. However, the new design sees a significant reduction in climate impact for families with multiple children. For a more realistic assumption of a mix between 100 milliliter and 200 milliliter bottles purchased of a child's lifetime, the dose doctor performs better. This proves that design for longevity is a key to offsetting the higher initial manufacturing footprint of medical devices. Next slide, please. Looking forward, we are focusing on 3 areas. First, reducing polypropylene content, as both LCAs highlighted polypropylene as a major impact driver. Second, improving end of life through better material selection and design for disassembling. And finally, exploring offsetting through verified carbon standards and formal carbon reduction plans to reach net zero goals. Next slide, please. Despite these insights, traditional LCA has bottlenecks. It is manual resource intensive and often happens after the design is finished. The lag effect to scale circularity, we need to shift a digital enabling. As shown in the table, we're moving towards automated real-time data is accessible to designer during conceptualization. To explain how AI is making this future a reality, I'll hand over to Roger.
Great. Thanks, Ying. Can everyone hear me all right? Yeah. Good. Yeah, nice to meet you all. Apologies, I was slightly late to this call. Yeah, my name's Roger Singleton. I'm CEO of a company called Riskwire, but that's just the company name. We run a managed service called LCA Factory, and that uses our proprietary software that's called MVDay, and we were one of the early ones to bring AI into the LCA workflow. We're by no means not the only one now. I think the AI revolution is well and truly here. But we have certain aspects of how we utilize the AI, but more importantly, I think how we overlay that with a human in the loop to create a genuinely faster but still trusted service is where we try and sort of position it. And what I just wanted to explain really today was where AI is impacting in the LCA workflow. I don't know if this is quick and easy to do. Just how many on this call could you do the virtual raise your hands? How many do LCAs day in, day out, or are you more providers of equipment in the medical domain? I don't know the demographic. Yeah, I know you do, Ying. That's is that the only one? Yeah, maybe. Okay. Well, hopefully you've got a bit of a flavour about LCA. And anyway, it is a skilled-based process, but it does follow a pretty, well-established methodology that's been around for, decades now. So the point about that is there is repeatability in the workflow that you can certainly apply AI to certain elements of that. And the trick is really knowing where you need humans, where you need AI, and how you keep everything trustworthy. So if you just quickly flick over to the next slide. Thank you. The reality is that the LCA is still, it's an incredibly powerful method, but we have issues going at scale. If you look at market-based data, it's generally understood that we perhaps do 150,000 to 200,000 globally per year that run through some kind of formalized process and through verifiers. That is minuscule against the number of product SKUs that are available. If anyone does or doesn't know this, Amazon alone has 450 million individual products that you can purchase on their site. So I think it's into the billions of range that there are products out there that probably could do with LCA information around it if we're going to action things around net zero or sustainability in general. Here's the problem. Currently, and I'm generalizing hugely here, LCAs are typically in the weeks or months ranges of how they're currently done. They are still fairly expensive, really. Each unit item can be 5, 10, 15,000 pounds, depending on the actual item you're going at. It can be higher than that, especially if you're into a multi bill of material kind of assembly point, etc. Data gaps are everywhere. It's way over 50% of the LCA practitioner's time that is spent grabbing or trying to find data and trying to bring legitimacy to the LCA underneath it. Even if your current reporting provider, the one that you're doing the LCA for, is great, their supply chain is likely not. So massive kind of issues there. And the problem is all this delay really puts down the line the real benefit of LCA, where I think testament to what James was talking about, that really you want an LCA to be informing you at design stage where possible. And at the minute, I'm not saying that can't be done, but at the minute that generally isn't how LCA is done at the minute, because people do it as a retrospective kind of compliance exercise, and they don't bring it in. So we have to increase the pace, not only for scale and coverage, but also usefulness of LCAs. So if you just quickly flick on, I'm just going to take you through 3 ways that we use AI under our LCA factory framework. And really, it maps to a number of the core stages of LCA. Firstly, we use it very much in a data collection and scoping phase. We then use it to automate modeling that then also gets an overlay of a human eye underneath it, but we are getting more and more advanced in terms of providing secondary layers of AI to do evaluation on the initial AI and lots of other techniques underneath. So that's speeding up. And then reporting is another area that we use it. And actually AI is great in this domain because it's very good already at development of content, and it's sharpening up a lot and making that very contextual and readable for an audience. Now, I put a big number at the bottom. I'm an engineer by heart, everyone. I probably should get better at sales and things, but I'm an engineer at heart. It's a lot faster in some areas. It is not the complete solution. It's getting better, but it helps in certain layers, definitely within the LCA workflow. But I wouldn't say yet it grabbed something from start to finish and we're a gazillion times faster. There's more complexity in it than that. So let's quickly go through how we do some of those aspects there. I've only got a few minutes. I'm just going to show you some background demoing of kind of how we do it. And it's a rotating video in the background, so I'll explain what it does and then give you a key output of where the AI helps with that. So if you just flick into the next slide, please, Ian. One of the stages, the early stages around data collection and scoping with LCA, you can read lots of research on this. They think that about 80% of all mistakes that happen in LCA are happen at the scoping stage, basically. And the problem with the scoping is you get that wrong, or you are data light, it cascades the amount of QA that you have to do later down the line with modeling. So one bit that we do with our AI modeling is, yes, we do the data parsing. To be honest with you, that's fairly easy and standard AI engineering now. You can take PDF, Excel, Word document, multiple data sources, and make sense of those. What I really like about the AI that we developed and we tuned it really to a practitioner problem is that we overlay that with verifying the grade level of the data that we've got for each particular part of the LCA, whether it's the inbound resource, the transportation information, or the process steps that we're going to have to model. And one thing that spits out of our first bit of AI is actually a primary and secondary data source evaluation. So it gives you a very quick hit on which parts of your model are actually related to primary data source and have a piece of evidence attached to it, and which have been done by what we call AI proxy, where the AI is estimated for you underneath. Now, that can be helpful in 2 ways here. First and foremost, rather than going back to the customer with a huge list, an Excel sheet of everything that you need to go and get them, you can start to find the top 5 things that need to source first that would have most impact on the LCA. So that's already a material improvement in the method of the process and the trustworthiness. Just to give you a bit of background, the scoping agent takes about 3 minutes to run. So you've already got that data quality understanding in around 3 minutes, which is fantastically helpful. If you just click on to the next slide, please, Ian. I'll just show you some of the outputs that we do against that. So, like I said, what the AI does is models very fast, but then we get a list out of where the key gaps are. And the best thing that we can then do is send back that request for information back to the client and say, I just need these particular pieces of information off these suppliers or from your foreground process. You can still choose not to do it, but we have to put the uncertainty analysis up against that. Now, I'm not saying that's perfect, but it is accelerating in the general workflow with LCA. And that's aside from the fact of it just sets up your model a lot faster than a lot of other traditional tools that still you have to build them manually. So that's kind of one cool aspect. The second one I'm just going to show you is probably our most powerful element within there. And that is that when you do LCA modeling, as Ying mentioned, that we use a combination normally of primary and secondary data sources. So the primary data is associated to the activity information, and that is the amount of goods and items that you would buy, whether it's a weight of material, plastic, the amount of travel, etc. And they're generally matched against an emissions factor data set, which is usually a secondary proxy, something like EcoInvent. The problem with those is as good as some of the proxy data sets are, that they're still very limited. They're in the tens of thousands of bits of information. And if you scale that up and think about the number of products that are available globally, we have a lot of data missing within there. So one thing that we do with the modeling is we use a decomposition strategy that if a proxy doesn't really cover properly, matching up an emissions profile to a piece of modeling, we can break each individual item down into a multiple layer sort of product breakdown structure that basically allows us then to match up emissions profiles to a more granular level. Something like a carbon fiber bracket, we can break that down into the carbon fiber winding, the resin production, and then the assembly-based process. And it's likely that we can get those more accurate individual data sets at what we call this subnode level canvas. And I'm telling you, that's the quality improvement side that you can do, but also that happens within minutes as well. And we have embedded AI evaluation capability as well, that basically gives a score and gives us gaps within the modeling, all within the space of about 5 to 10 minutes. So again, it allows us to triage and go back and either get clarifications on bits of the modeling or do some internal modeling with the human in the loop to accelerate that much faster. If you just flick over to the next slide, please, Ian. I think it's just an output. Yeah, so that's just showing sort of the idea that we can take complex items or processes and very quickly break them down into individual granular levels. And each of those has their own environmental impact. That also, by the way, has a very useful application in product design, because you're then not choosing where the environmental impact is over an overarching proxy. It's actually breaking it down for you and maybe giving you information like 10% of your CO2 impact for this process stage is coming from the waste provision, and that's actually very actionable at an operational level, whereas a lot of high-level approximation isn't. So those are like the two big plays that we do. I mentioned a third one that we also do in terms of reporting, but like I said, AI is very common in content gen now. But at the reporting stage, it can also do other sort of very useful complexity elements like understanding uncertainty analysis, running it through something like a Monte Carlo simulation, which is an overlay between sensitivity analysis and uncertainty analysis, and give you that kind of overarching understanding of how near or far your model is at that point in time. So if you just flick through again, thank you. So what I think is more the breakthrough is not AI or human. I think it's an integrated hybrid, personally, that we very much do the LCA delivery like a production-based system. So we have it with QA checkpoints. That's where the human's in the loop, but we use the AI almost like a machine tool would be in a factory space. So we allow the AI to do certain parts of it, whether it's scoping, modeling or something, and then it comes to the QA gate ready for the human with the relevant metrics and scores before you then either change, edit, update, or move it on to the next system state within there. And underlying all this, that's the what we do. And all of it, hopefully, if we can help out in any way, is all about this idea of can we get back into that product design cadence workflow? You know, product designers meet weekly. We can't be waiting 6 to 8 weeks for an LCA or several months. It's not, as an industry, we're not going to be then providing the impact to anyone. Okay, that's it from me. Thank you very much, everyone.
Thank you very much. That's a perfect, I think, perfect presentation, and from that presentation, I think we start to understand why the circular design is very important, and then James gives us a kind of perspective from the industry side as a SME. So what's the obstacles, or what's the kind of the barriers for them to incorporate the eco design in the product design? And Jean tell us how do we quantify the environmental impact, and Roger gives us how the AI can scale up, accelerate the process. So thank you guys. Perfect. So any questions? Yes, we got question. Oh, there's a question for James. So knowing what you know now, would you have incorporated circularity thinking earlier in design and the prototyping process, or did it make sense to do it in the place order you did? For example, if you were starting again tomorrow with development, where would you put this thinking work?
Yeah, I mean, that's a really good question. I mean, as a consultancy, we're thinking about this problem all the time now. I think, one, piece of knowledge or, education we didn't have was the vocabulary used, and what was being measured and how we could be more sustainable. So I think in terms of where we put it, from a resource perspective, I think we would want to kick that down the line as much as we can. But I think now we understand that, even a preliminary LCA gives us a set of definitions, or that line in the sand, as I mentioned, that we can now, understand with design for manufacturing stages, whether it gets worse, better, or doesn't change. And I think that would be something that we'll implement into our, projects in the future.
Yes, I absolutely agree, because as a researcher, when we look at the literatures and policies, it always suggests to put eco design at a very early stage of the design process, even before the technical design. So thinking about the materials, thinking about the function of the products, that's very important. Thank you. And Yuri.
Yeah, morning everyone. Thank you for the presentation. It's really insightful. I have a question for Roger. We are kind of starting this, I would say, era where we need to use the tools, and these tools, like AI, software, internet, they look like they don't have a cost, but we also, because we are close to sustainability, we know that all these tools have costs. So how can we include the cost of using software or those decisions of computation into the life cycle assessment? Now that you are using AI inside your tool set.
I presume you mean environmental cost, sorry, of that.
Yes, here, environmental
Yeah, sure,
cost.
yeah. What I find extremely interesting about that is that no one ever asks a manual LCA practitioner that spends 6 weeks on his computer in a lit building to do that. But that's fine. I spend my life defending this. So we automatically track token usage, and also we track practitioner time at every stage. So we have an internal improvement plan around improving the unit economics of LCA anyway. So as soon as you track compute usage and practitioner time, you can do loads of things with that. You can look at your bottlenecks, you can look at your cost, but you can also look at the environmental impact of that. I think this year we will probably start to put our own executed CO2 profile from conducting the LCA on the platform. When we did an exercise on this about 12 months ago, to do an LCA, we were about a third of the CO2 footprint of a manual practitioner doing it, but that was mainly because of the time it takes for the manual practitioner to undertake and do the analysis. But I agree with you. I think it should be stated, but I'd also say the playing field should be stated. And if we do that, I think manual practitioners should do it as well, of how much impact it took for them to do the report on the way.
Yeah, I think maybe in the same kind of path. Have you seen any kind of change of behavior or thinking when people know the value, environmental value and cost, and also the normal cost, like economic cost, when you show the different LCAs of different paths? Like, I don't know if we as a society, we really lack of awareness of the cost of all of our decisions. So
yeah, I don't think we cover most of our understanding of decisions. I'll give you the honest answer. The majority of our customers come to us because they're under compliance pressure, and it's something either around B Corp or CSRD or some kind of tender-based LCA that's needed. And in all honesty, they're deadline driven, and they need a faster turnaround at the same trust audit level. And I don't think they don't ask very much about that particular side of things. I think they just breathe a sigh of relief when they've got their document good to go. But it's a great question. It does worry me, right? Because for us to do one LCA, and let's take that comparative where we were a third of the carbon footprint. The problem with that is we were probably 100-fold or 150-fold less in terms of time of delivery. So if you then do that, that's not matching up, right? So if you then do more LCAs, then obviously your CO2 footprint goes through the roof. Yes, I worry about that. The CO2 per token usage is coming down as more and more data centers are located in certain areas, more renewable use, etc. A lot are tapping into potential nuclear source of energy, but that doesn't stop the impact of dumping a load of data centers right around our pristine habitat. I get all that. But I think what I do in reverse, what actually worries me more than whether the AI has a footprint or not on the LCA, my biggest worry of all this is I honestly don't know how many LCAs actually lead to some actionable change. And if they don't, we are just an overhead cost in terms of sustainability. All the conferences we go to around discussing LCAs, all the activity we do on it, everything. If they're not actionable, we're just adding to that environmental overhead, basically. So part of the play is if you get an LCA earlier within the design stage, there is a more realistic chance that you might get a design change into that phase, which I think is impactful. But none of this is easy, right? I'm at a sustainability accelerator this week with a ton of other startups that are all trying to tackle sustainability, and they've all got difficulty enacting change in different environments. Yeah. The good thing is, I think we probably track our resource usage better than any manual practitioner out there, personally, because we do time as well on it very, very accurately.
Yeah, thank you so much. I think, yeah, we all share the same worry. Good luck.
Thank you.
I have a question for Jane, because it's great to have a kind of look at the evidence, the quantitative evidence of the LCA analysis for both the traditional syringe and then Dr. dose. But I want to know, because there is multiple perspectives around eco-design, you evaluate the carbon emissions and yes, materials. But I want to know, have you looked at the waste reduction into the LCA analysis? Because obviously there is huge kind of waste reduction in the reusable medical devices. So have you looked at that in the
for this
analysis?
For this project, so we conducted this project about 1 year ago. I don't think we look at the waste management But I think this is a very complex task to do as well, because anything related with medical devices need to associate with different regulations. And then, so if there's any waste from material from the manufacture process, will that material still be okay to reuse for the medical device production, or do we need to use it into another purpose? I think that will be a big task, or like even a big project for us to do in the future. Yeah. I don't know if James will be interested in, and then we can work together in the future and look into those things.
Yeah, I think absolutely. I think, just to come back to sort of Judith's question, we are interested in, and as per Roger, we have the ability now to make changes based on our LCA.
Yeah.
So I think, the more we can do in this space, the better. But again, we still face this, face the same resource constraints problem. And I keep coming back to that, and that's because, if it is just a sticker that you can get 10 minutes before you submit your dossier, there's the skepticism about why the small company should do it and not the large company. So yeah, it's really interesting to hear your thoughts on sustainability, but yeah, absolutely, Jane. I think the more we can learn, the better from our perspective.
Great. Any more questions? Yeah. Great. So thank you very much. I think it is a fantastic, and for me, it's a fantastic webinar, and as a researcher to learn from the industry, from the in terms of the product design and the new technology, the digital tools, how that can accelerate the process, the LCA process. This is wonderful. Thank you so much. So if there's no questions, we're going to end this webinar. Thanks for joining us. Thank you. Hope you have a lovely day.
Thank you very much.
You.
Thank
Thanks.
you.
Yeah, no.
Thank you,
Thanks,
everybody.
Rob. Bye-bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.